The natural log is defined by the integral from 1 to x of 1 over t dt. And the domain of a natural log, remember, looks like this. It has a vertical asymptote at x equals 0. So the domain is x is greater than 0, or all positive real numbers. All right, so some properties of logarithms that you may remember. The natural log of 1 is 0. Remember, there's an invisible e, so e to the 0 power would give me 1. Invisible base of e, so e to the what gives me e? That's 1. From the limit as x approaches 0, from the right is negative infinity. And the limit as x approaches infinity of the natural log of x is also, or is infinity, because it increases forever. So the natural log is always increasing, and it's concave down, meaning the tangent line can be drawn above the curve for the entire function. Okay, good. Properties of logarithms. So like we said before, ln of 1 is equal to 0. ln of a times b gives me the product property of logarithms. So ln of a plus the ln of b. We multiply the bases, we add the exponents. Okay. Power property says I move this n to the front. So I have n times ln of a. And then the quotient property says that I subtract exponents when the bases are being divided, like so. All right, let us find the derivative of ln. So the derivative of ln is 1 over x. Okay, if you look at our ln function, the function is increasing very fast and then very slow at the end. So but it's still positive since it's increasing. So it's going to go like, get slower and slower. And notice that looks kind of like the branch of a rational function. Okay, that's a sketch right there. Okay, so this is 1 over x. All right, so the derivative of ln u, this is chain rule, would be the 1 over u, which would be the input here, 1 over u, times the derivative of u, so du dx, or we can write that as 1 over u times u prime. Okay. And then the derivative of the absolute value of u would be 1 over u, is the same, 1 over u times du dx, so the derivative of u, so that equals times u prime. All right, a couple examples. So we're going to find the equation of the tangent line to y is equal to the ln of 2x when x is equal to 2. So derivative of a tangent line, or the slope of the tangent line means we're going to have to get the derivative. So let's take the derivative of y. We'll get y prime is equal to the ln of 2x. The 2x is the u. Okay, so the ln of u, the derivative of ln u is 1 over u. So it's 1 over 2x times the derivative of the inside, which was 2. Okay. And then, so this is our du dx, and this is our 1 over u. All right. So we simplify, so y prime is equal to 1 over x. And then we need to find the value of the slope when x is equal to 2, so 1 over 2. And then we need the point on y at x is equal to 2 is y of 2 is the ln of 2 times 2, which is the ln of 4. So the graph goes through the point 2, comma, ln 4. So now we can write our equation and slope point y minus the ln of 4 is equal to 1/2 times x minus 2. All right, number 2. All right, the derivative of ln 5. Guess what? ln 5 is a constant. What's the derivative of a constant? 0. We're going to find the derivative for f of x is equal to the ln of x plus the square root of x plus 1. Sorry, the ln of the square root of x plus 1. I am going to rewrite this because this makes me uncomfortable. The ln of x plus 1 to the 1/2 power. And then I see I have some power property going on. So this is f of x is equal to 1/2 times the ln of x plus 1. And then it's time to take the derivative. We have f prime of x is equal to 1/2 times 1 over u. My u is going to be the inside, x plus 1. So 1 over x plus 1 times the derivative of u, which is just 1. So I get f prime of x is equal to 1 over 2 times x plus 1. Or if you want to write it as 1 over 2x plus 2, that's also an option. All right, number 4. Lots of examples today. All right, find the derivative, dy dx, for ln y when x is, for ln y is equal to x squared plus ln x. I don't know where my head is today, but try. Okay, here we go. So I see we got a lot going on here. My x's and y's are they're not mixed, but I don't have y isolated, so this is an implicit equation. So I need to use implicit differentiation to solve. Here, remember tacking on dy dx for anything that is not an x. So the ln of y would be 1 over y times dy dx, and that's equal to, all right, it looks like I'm going to use the product rule. I'm going to use x squared as my left and ln x as my right. So lefty right, so x squared times the derivative of ln x, which is 1 over x, plus the right, ln x, times the derivative of the left, so 2x. And then we just solve for dy dx, so I'm going to multiply by y on both sides. So I get dy dx is equal to y times x squared over x is x plus 2x ln x. And we dunsies with that one. Put it in a rectangle. All right, number 5. Find the second derivative of y is equal to the ln of x. Gross. All right, we have y prime, or dy dx, is equal to, this is definitely chain rule. I have the outside function is ln of x, the inside function is ln of x, and the inside function is ln. So I have the derivative of 1 over the inside is the ln of x, okay? 1 over u, so 1 over ln x, times the derivative of the inside. You see the chain rule happening here? Okay, so the derivative of the inside is 1 over x. The ln of x, derivative of the inside would be 1 over x. So this is 1 over x ln x. All right, let's find the second derivative now. And I notice that I'm going to use quotient rule because I have a division here. You could also use chain rule, but I think I'm going to use quotient rule. Okay, so I have low d high, x ln x, d high is 0, the derivative of 1 is 0, minus high, 1, times the derivative of the low, and I'm going to use quotient rule on the bottom, so, or product rule, sorry, left d right, so x times 1 over x, plus right d left, so ln of x times 1, all over x ln x squared. All right, let's just do some simplifying. So this first term is going to cancel to 0, and then it looks like my x's will cancel to 1. And so I just end up distributing the negative, giving me negative 1 minus ln of x over x ln x squared. Not so bad. All right, number 6. We're going to find dy dx in terms of x, so any kinds of y's that we have left over, we need to swap them out for x's. All right, so let's take the derivative. Okay, there's a little trick here. Because this is so complicated on the right-hand side, what I can do is take the ln of both sides. It's a little trick. ln of y, because the derivative of ln is nice. It's very easy. So the ln of this whole crazy thing on the right, x times the quantity x squared plus 1 squared, over the square root of 2x cubed minus 1. And I remember all about my ln rules, my log rules. I can split this apart to be the ln of x plus the ln of x squared plus 1 squared minus the ln of 2x cubed minus 1 to the 1/2, right? So then apply the power rule. Ln of y is equal to ln of x plus 2 ln of x squared plus 1 minus 1/2 ln of 2x cubed minus 1. I just taught this in pre-calc, and I just bragged to them how we use this to solve a problem. Properties of logs. You thought you'd never see them again. Okay, so now we're going to take the derivative of both sides. So we're going to take the derivative with respect to x. So we have 1 over y times dy dx is equal to the derivative of ln x is 1 over x plus 2 times 1 over u, so x squared plus 1, times the derivative of the inside, which is 2x, minus 1/2 the derivative of ln 2x cubed minus 1 is 1 over 2x cubed minus 1 times the derivative of u, which is 6x squared. All right, solving for dy dx, so we're going to multiply both sides by y. Okay, and I get dy dx is equal to y times 1 over x, and then we'll simplify, plus 4x over x squared plus 1 minus, it looks like the 2 and the 6 are going to cancel to give me a 3. So 3x squared over 2x cubed minus 1. Got my squares and my cubes all right. And then remember we said in terms of x, So we need to swap out this y, but the equation is already solved for y, so we can just plug this in. So really, this is just like torture for my hand because it's a lot of writing. But the y is equal to x times x squared plus 1 squared all over the square root of 2x cubed minus 1 times 1 over x plus 4x over x squared plus 1 minus 3x squared over 2x cubed minus 1. And that's that. Okay, I hope you guys enjoy. Bye.